Hi, my name is Rodrigo España, and today I'm going to be teaching you about hydrocarbons. The first and most important thing you need to know about hydrocarbons is that they are the simplest organic compounds. The reason is because they only contain carbons and hydrogens. So I here will draw you the perfect example. The reason why I say this is a perfect example is because we can clearly see there's just carbons surrounded by hydrogens. There's just carbons and hydrogens. That's what makes them the simplest organic compounds. These in a skeleton would be drawn like this. Here, one carbon, two carbons, three carbons. One, two, three. Now I'm going to teach you about the main three groups, the three groups of hydrocarbons. The first one is the alkanes. Alkane. The reason why this is the first group is because it does not contain either a double bond or a triple bond. So in a skeleton, this would be something like this. Well, if you know how to name them, this would be really simple. Here we find 1, 2, 3, 4, 5 carbons. Well, in this case, we did not get into 1 to 4, but here is the namings for 1 through 4 with are right down here. But I just put up to 4 because after 4 is the normal we've always known, like pentane, hexane, heptane, octane. But this, by having 5, as I just said, it would be a pentane. The reason why it's pentane is because of pent, 5 carbons, and alkane, the ending. It's really important. The second group is the alkynes. This, as different as the alkenes, has a double bond, which I would put it right here. This makes a whole difference because by it having a double bond, the naming would change to, because you always pick the double bond to the closest as you can. So it would be, I would start from this side, 1, 2, 3, 4, 5. So this naming would be 2/pent. Here, all I changed was the 2 and the ending, the pentine. The reason why the ending changed is because of by it having a double bond, it converts it automatically into an alkyne. Here, the ending is also really important. And the third and last one are called the alkenes. Here I'm going to underline the ending. Alkenes are triple bonded. So here I would do the same. So I would start from here because it always has to be from the closest one. 1, 2, 3, 4, 5. And this would be just the same. All you would do is change the ending from ein to in. But something you gotta be really careful on is when you have your skeleton drawn like this. This might be really confusing because at a first look, this would be like just having 3 carbons, 1, 2, 3. But no, it's still a pentane because here it's an other ending and an other ending. So you might as well put carbon, carbon, and leave it this way. This way you can clearly see there's 1, 2, 3, 4, 5. So it would be the same. This is just to point out that the geometry of the carbon is linear geometry. So by this being linear, being an alkene means that this is an sp and this is an sp2. Electrons always rather be in an s than being in a p. This is an sp2 p s sp2, and it would be an sp3. By this being sp, as I already told you, electrons always rather being s. This makes it the stronger electronegativity, well, the higher electronegativity, which this means that an electron would rather be in an alkene than an alkane or alkyne, because of it having a higher electronegativity. Here, the S character is around 50%, and here the S character is just like a quarter. So that makes the whole difference. This was all for today. I hope you learned and you like it. See you.